Welcome to Disambiguation. I'm your host, Michael Fauscette. Each week, we interview experts in artificial intelligence, generative AI, and business automation to help business leaders understand how to use these tools for the biggest business impact. In our show today, we're going to take a look at the role of AI in code maintenance. I'm joined by Matt Van Itallie, founder and CEO of SEMA. Matt, welcome.
Michael, thank you so much for having me. I'm really looking forward to it.
Yeah, this is a really interesting topic, and I think it's something that the audience. It's not something we talk about that much, and I think it's one of those things that is extremely important from a overall AI strategy perspective. So why don't we get it started? Just tell me a little bit about yourself, and then let's talk about SEMA's origin story. How did you get the idea? What inspired you to focus on code maintenance?
Absolutely. So I am the son of two computer programmers, and one of those computer programmers became a math teacher. So looking backwards, it was clear that I was born and raised to treat code as data. But I took a lot of winding turns in my career between the start and now. I studied history and economics, was an advisor as a management consultant to governments and private equity, did some work working with teachers and principals on using data to improve teaching and learning, which is a topic near and dear to my heart. And there's some meaningful similarities between how teachers and principals engage with data as software developers. So there's a fair amount of overlap there. I went into ed tech and HR tech for the nonprofit industry. And along the way, both became really passionate about what does it take to help software companies get better and software teams get better. And also, I was pretty tech savvy and very data savvy, but was not a professional coder. And I was always flummoxed by how hard it was to understand what was going on in the engineering organization. I'm sure everyone on this listening to this podcast is very familiar with CRM tools. And while CRM tools are extremely useful for individual salespeople and sales managers, they also serve an executive insight into sales problem, which is to say they help the chief revenue officer talk about sales with the rest of the C-suite and with the board of directors. Software development has an infinite number of developer tools. Thousands of them are great. Hundreds of them are great for engineering managers. But in terms of, is there a single source of truth that a CTO turns to explain the state of engineering to the C-suite and the board of directors? There is not, unless they build it themselves, their homegrown tools. And I love logic, and I love solving problems that matter. And this most certainly matters, because if engineering and finance and sales don't understand each other, we get suboptimal outcomes, whether that's not enough investment in reducing tech debt or too much or what have you, and really could make organizations so much better if the leadership could really be aligned. So that was the origin story. SEMA, for what it's worth, we spent some time thinking about that name, comes from a famous translator. The full name is Lokaksema, although I'm sure I don't speak Sanskrit, so I'm not doing justice. And Lokaksema brought Buddhism from India to China. So an incredible translator of a really powerful idea. The segue is that we at SEMA, we're not the creators. We pay homage, to the software developers who are doing the work of creating, but we help translate those results so that other people can understand them and try to expand their impact. And from Lokaksema just to the SEMA, it's last four the last four letters.
Well, it's interesting because I've been in this business for quite a long time, and it is true though that as an executive, you have visibility into lots of your business, but that's the one area that you don't really have good visibility into. I mean, even all the agile tools that are out there don't really help from a executive perspective. So why do you think that is? I mean, why does code maintenance often take the back seat, and how do you, your company, bring that to the forefront?
Yeah, so there's two main reasons why there isn't let's call it a CTO dashboard that's really predominant.
Mhm.
One reason is it's really freaking hard. So if you, CRMs are also hard, I promise, and there's a lot of
Mhm.
functionality, but when you get it right for US dollars, if you want to bring it to Australian dollars or euros
Mhm.
or pounds, it's a conversion. I know it's very hard, but it's a conversion. By contrast, if you get a CTO dashboard right for Java, that tells you almost nothing for JavaScript or Fortran or COBOL or any of these languages.
Yeah.
So the actually only way to do it at depth, like you can have a cursory level that just talks about the metadata about what coders are up to. But if you actually want to do it at a meaningful level, you actually have to do the work of understanding each of those languages.
Mhm.
At SEMA, our first product, comprehensive code base scans, we all kudos to our extraordinary researchers, engineers, and product team. We tackled language by language how to solve this problem, but not in a SaaS version, in a report. So for folks in
Mhm.
America, you can think of it like a home inspection. I think for the global audience, taking your car to a different mechanic and getting a report on how much maintenance there was from the previous mechanic, that's the
Mhm.
analogy. So it's a point in time report.
Makes sense.
It's gives an answer that we think CTOs and boards of directors want to see, but it wasn't SaaS first. And so it's a really, really hard
Mhm.
problem. Took us 6 years to get that right. Before we then started working on the SaaS version, which is it's coming out in 2025, and we're so excited about that. So one reason
Mhm.
it's very hard. The second reason is, cobbler's sons go barefoot. It's really hard to be in the organization, to be in a role, and then step out and see how you can do things differently, especially since many of the folks in the role would really enjoy building the bespoke dashboard for themselves. Right? You're not going to find
Mhm.
many CROs who would like to build their own version of a tool. That's
Mhm.
not what drives their passion. Whereas it's this amazing thing
Yeah.
about the craft of code. And it is a craft. It's different from many other professions. It is a reward to do more of it. I lead product, help lead product at SEMA with our head of product. I also do sales.
Mhm.
Um, it's not a reward as a sales leader to do more sales. It is a reward as a coder to do more coding, right? And
Yeah.
so I think from that you would expect to see so many of these homegrown tools.
Hmm. Yeah, that makes sense. In the way that you've applied this technology, and it sounds like you have the capability now from language by language to go really deep into the code base. So is there like a methodology that you teach around this? And how do you set yourself apart from any of the other tools out there from a code maintenance perspective?
Yeah, for sure. So, of course, there are many extraordinary developer tools, and which we are not, that help with code
Mhm.
maintenance and code development. Many, 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 and there new ones are being created every day, especially with the rise of Gen AI assisted coding. I think what SEMA does pretty well, and it all comes hopefully from really, really listening to our audience, to
Mhm.
CTOs, and then also what the CEO and the board of directors and the head of M&A need to know, which is obviously at a much lower level of detail
Mhm.
than what the CTO and the CTO's team is to really think a lot about communicating that information in a way that is easily understood. If I could, on the side, I spent many years working in public education and you know learned about education theorists. And one of my favorite quotes of all time that I think is incredibly applicable in all areas, including what we do at SEMA, is from Soren Kierkegaard from the 1800s, who said, "If you want to be a teacher, the first thing you have to be is a learner and understand what your audience knows, and paraphrasing slightly, meet them where they are." And I think so much of communicating, especially on complex topics, boils down to can you make it easier for your audience where they're coming from? A tiny, tiny example. One of the things we do in understanding the health of a code base is looking at security warnings of a code base. Now,
Mhm.
your audience may or may not know every code base on earth has security risk.
Yeah.
I didn't know this before starting this business. I thought it was you either have some or you don't, but you can solve it all. You can't solve it all. It's you have to. There's a running
Mhm.
amount of security debt so to speak, just like quality debt that every organization faces. We run a scan that will produce a number of security warnings. And let's say that number is 100, high risk security warnings. By the way, identical or incredibly overlapping with the same developer tools, because we're the other car mechanic. We want to see the state of the tools that, and the state of the usage of the tools previously. So if you have 100 security warnings, what do you do with that 100 as an executive? Well, it depends. It depends on what? What's the stage of that organization? And so we put that 100 into context. We have segments for the targets or the code owners that we look at. Baby companies have a different profile than giant established companies. And then we do relative benchmarking. If you were a software company that's 6 months old and you had 100 high-risk security warnings, something's really weird. That would be very bad, and like you'd almost have to be trying to have that many security warnings that early stage. Having 100 and you're a 5-year-old company is pretty reasonable. Having 100 and a 20-year-old software company is best in class. And so we produce the absolute numbers. They're available. You can see that 100, but we lead with the relative number. You're in the first quartile, you're in the fourth quartile, etc. And summarizing it like that, well, of course, letting engineering teams and leaders see the detail, because they're going to need it to understand it, to validate it, to do the cleanup work, makes a really big difference. Meeting your intended communication audience where they are.
Yeah, I mean that's a good lesson. Context matters, right? That's important to understand in relation to the overall assessment. Where am I along that curve? And I would assume criticality and that sort of thing too, right? I mean, a low priority, low criticality rated problem is different than a highly, rated important. So, yeah, that makes sense.
Exactly
Well,
right.
Oh, go ahead. Sorry.
Yeah, so a tiny example of that, we create a 1 to 100 score of code base health. And that is, those of you who don't know a lot about code, let me say that has chutzpah to try to summarize a code base and all its nuance into a single number. I will say it took us 5 years, 750 code scans before we felt confident. It's not hard to create a number. It's hard to create a number that's defensible. And that 100 score, just imagine, audience, there are thousands of metrics you could care about when you're thinking about an engineering organization, cyber and intellectual property risk and team and da-da-da. From those thousands, we have about 50 that we consider moderately important. And from those 50, we picked 12. So if you'd like a thought exercise, you can think about, if I could only know 12 things about a code base to decide if it was healthy or not, which ones would I choose? You can check on our website, because we have the answer. Our perspective doesn't mean it's necessarily right, but if you want to see the answer. And so most metrics are in the 1,000 group, which is they don't even make it anywhere. Some metrics make it to the 50, and only a few make it to the 12. One of the ones that makes it to the 50 is the number of warnings from linters. So linters are like, it's like a Grammarly check. It's the equivalent of looking for spelling and grammar in English. This is about syntax. It's a really good idea to use a linter because it helps keep the team organized. And so it makes it the top 50, but it does not make it the top 12. Something that makes it to the top 12, and in fact is the number one item, I'm not telling too much of our secret sauce, is developer retention. So it turns out from all of our research, the most important thing about having a healthy code base is not the code, it's the coders. Because if you have the code and you don't have the coders, I liken it to having a half-written novel without the novelist. You're really in trouble, because the logic, no matter how good documentation is, the logic is really in developers' heads or key subject matter experts' heads. So almost all code metrics we don't even talk about, to your point. Linters are on the 50, but not on the 12, and things like developer retention are on the 12. So not only contextualizing it, but you're exactly right, Michael. weighting them accordingly in an opinionated way that is actually tied to the research.
Hmm. That's interesting. I was just thinking of the CEO of this cloud ERP company that I was talking to many, many years ago when I was at IDC. We were talking about code and cloud and how that was different, and took away a lot of debt. And he goes, it's like most businesses that have the code bases that evolve over time end up with a bunch of hairballs in the code, and it's really hard to take care of that sort of debt. And I think that's a good way to think about it, right? Hairballs in my code, I don't want that, so I need to get rid of them.
Exactly right.
Um,
Exactly right.
so you mentioned AI development at generative tools for coding, and it's so common now in the conversations I have with CTOs and R&D and developers, that sort of thing. It's very, very common. But I'm curious about that though, because how do you ensure code quality, and then how do you know that you're going to get the expected outcome when you're using these generative tools?
Yeah, it's an amazing, amazing question. First and foremost, we at SEMA are absolutely bullish on using Gen AI tools to code. Now you have to pick the right one. There's several that are great,
Mm,
and you have to pick the right tier, which really, really matters. But big picture, we are nothing. We are absolutely bullish. The benefits, just so we know it, include increased throughput and productivity, and also increased developer satisfaction. Not everyone loves it yet, but many do, and there are so many ways it can help free up engineers from tedious work and let them do the things they do best of solving problems. If anyone's listening to this and you have a developer who is skeptical about using Gen AI, ask them to compare and contrast open source code with Gen AI code. Open source code, of course, is code they didn't write, but it makes them
right.
more productive. It avoids drudgery, and it comes with some risks that need to be managed, including code quality, as you said. In our view, Gen AI is exactly the same. It's really good for
Mm,
productivity. Imagine not using open source and how much slower you would code. Once you get used to it, it's really delightful in many
mm,
cases. Doesn't do everything, but it's really delightful for engineers. But it comes with a series of risks to be managed. If you're listening to this and you don't like that analogy, please write me, because I love talking about this and refining it. So I would be thrilled to either have an argument or a nuanced discussion on the analogy to open source. So now, Michael, then to the risks. We see 5 risks of using Gen AI code to Gen AI tools, whether they're general tools like a Claude or a specific tool like a Copilot, to code, all of which can be mitigated. One of them is code quality. Let me just list them. So exactly right.
good.
I definitely agree. Second is code security. Third, intellectual property risk.
Mm,
Fourth, exit risk. And then fifth, insufficient usage leading to insufficient productivity and satisfaction. So that one is the simplest. It's so valuable that if you don't use it enough, you are leaving value on the table and joy and goodness for your developers.
mm,
I'll do them in reverse order so we can get to quality. It's the one you cared about. Intellectual property risk. Under certain circumstances, if you use Gen AI code or the wrong kind of tool or the wrong kind of tool the wrong way,
mm,
you may put your intellectual property at risk. The simplest example, although there are many, is that if you use a free tier of a tool to code and you put in your company's code, that's like
mm,
posting your code on the internet
right.
because it's going to be reused by the model. And so there are tips and tricks to manage, and you have to do this in consultation with your legal counsel to make sure if you're a meaningful business or not-for-profit or government concern that your IP is protected while you're using these.
Mm,
Security is also a risk. Gen AI code creates security shortcomings. Guess what? So does open source. So does humans from your
mm,
team. So
yeah.
the good news is it's a very straightforward solution. Just use a high quality security tool, of which there are many, and make sure it's reviewing not just the code that your team has written, but all the code on your team. Then there's something, number 4 is something called exit risk. And that is if you're a company that might ultimately sell your business,
Mm,
buyers are going to consider how much generative AI is being used. And they're going to look at it in some part for intellectual property reasons. If you were using the wrong kind of model, there might not be the intellectual property might be, or the right tier might not be protected. But also, just imagine you're an ERP company and you decided you wanted to buy an ERP for garden tool stores. I love gardening, so I'll just use that as an example. If you did a diligence and you found it was 100% written by GenAI, well, guess what? The value of that code is less, because if GenAI could write 100% of that code, and maybe your team using GenAI could build a competitor more easily. The solution is to make sure that your GenAI code is really proprietary to you, and the way to do that is blending it. So we say GenAI code that comes straight out of a prompt is pure. When developers add their expertise, not just pre-prompt, but now post-prompt, we call it blended. Blending the code solves a variety of problems, including making sure that the code is distinct and unique to the organization and therefore more valuable. That's risk 4. And it turns out, finally, this is a very long answer, but hopefully it makes sense. Back to code quality, the code could be incorrect. It makes up packages, right? Hallucination is a real thing. It could lack context and knowledge. Again, the good news is we have tools and methods in place to keep code quality high. Absolutely, number one, my favorite, is code reviews. There is no substitute for humans looking at code at least one, sometimes 2 or 3, depending on the significance of it, to understand it, to make sure it makes sense, etc. Testing is also critical, and then whatever set of code quality tool suite of code quality tools, also those. The really short version is you can't trust code coming out of GenAI in the sense that if you're doing anything that's high stakes, you have to double check. But you can double check with all of the ways that coders, as professionals, as craftspeople, use to keep code high quality from whatever its source is.
I mean, that makes sense. I mean, if you think about it, that's the same advice I would give a content marketer who's using, ChatGPT to help them outline and build content, right? You have to ensure the quality of the output, and the same obviously true with code in some ways, and even greater risk to the business. So that's interesting. The other challenge, I hadn't really thought about this, but this is really interesting from a value perspective, right? The value that we add from an IP perspective in a company is, that's how you develop that, and the revenue, how you develop the value that you would, if you were doing an exit of some sort. So that's a challenge I hadn't thought of. And it sort of brings me to the next question. I was thinking about this, and we talked, several of these would fall in this category of misconceptions or challenges, but are there other things from an AI generated code perspective that you think companies should be aware of, misconceptions and other challenges that they might face in maintaining that code?
I think I don't know if they'll call them misconceptions, but I think a couple tips that I would really strongly recommend. One is there are suites of tools, again, general or specific, that can help with the software development lifecycle that aren't just about code generation. One of the things that GenAI does is understand corpuses of data. So back to that hairball example, using GenAI to help understand what does this code do. It's a way faster way to get up to speed on code bases, to either create documentation or to use it as you go to understand. Same things with tests. GenAI can make it a lot easier to add the testing coverage that is appropriate. Again, you still have to review the tests to make sure they're correct. Some audience members, like me, used a typewriter a really long time ago before switching to a word processor. I know those words are foreign to some of your listeners, but I certainly remember distinctly realizing that the cost of each word I typed decreased dramatically when I switched to a word processor, because in a typewriter, you might have to white it out. You might have to redo the whole paper. So you had to be you had to be a lot more intentional on each word you typed in with a typewriter than a word processor. Well, it's exactly happening now with Gen AI, not just for code, but including code. Ethan Mollick, a great AI scholar, says intelligence is now cheap, judgment and wisdom is hard. And so now it's a lot easier to create much more volumes of code because have you seen Inception, the Christopher Nolan film from a few years ago? Those world builders who just think of a world and it just unfolds out. That is like Gen AI. I really hope everyone here, whether or not you're a coder, you're experimenting professionally and personally to understand its value at all these different stages. Another way of saying that, though, is with a few lines from the human, you can create huge quantities of code. And so that volume has to be managed differently through code reviews, through automated tools, through understanding it. That's one, if it's not a misconception, it's getting ready for how much cheaper it is to produce code and therefore how much more volume it is. The second thing is I would really be working hand in glove with legal counsel. Those who've spent time thinking about the use of open source know that it is it's incredibly valuable, but in certain situations, it is extremely high stakes from an intellectual property perspective about what kinds of open source licenses you're using, such as in diligences, such as in certain procurement processes, such as for certain kinds of insurance. And there's a whole industry, software composition analysis, that's about how much of your code is open source and what the legal risk is. That is coming for Gen AI. That is coming. It's not here exactly yet, but it's gonna. And do not make sure your legal counsel is involved, internal and frankly your external IP counsel, and be ready for it. Just as a tiny preview, one of the ways you can protect your ideas is through patents. Patents protect the idea. The U.S. Patent Office, and I believe every patent office around the world, has said we protect a human's idea. So as long as a human created it, it's okay that you use AI to implement it or refine it, etc. So we do not predict at SEMA that there will be meaningful IP risk to patent protection of code from Gen AI. By contrast, another kind of IP protection is copyright. Copyright protection is protecting the work itself. Books get copyright. Art and music gets copyright. If you're at a major organization that produces software, your code is getting copyrighted by your copyright team. The U.S. Copyright Office has said, by contrast to patent, AI-generated works do not get copyright protection. Well, it's public news that Google is using Gen AI in 25% of their code. Now, I'm sure most of it is blended, but there is a real disconnect between what the Copyright Office is saying about what they're going to protect and organizations who are seeking copyright. So get your legal counsels involved, and it is our prediction that the world of intellectual property management of code created in part with Gen AI will be analogous to the world of intellectual property protection of code using open source, which is a giant risk, overcomable, but a giant risk. And so we'd want people to be ready for, when the lawsuits happen, when the Copyright Office announces news, etc. So it's not, the tech team and the legal teams are going to be ready to jump.
I mean, that's often the case with new technology, right? The regulatory compliance governance side of it has to catch up to where the technology's taken us over a period of time. So I guess I'm not surprised to hear that, although it certainly is a concern for a lot of businesses right now if that is going to be challenged and how that is going to be defended in the future. So that's
and just like open source, we say absolutely use it, but just be ready to defend it and protect yourself. Be ready to explain how much of your code is Gen AI versus not, et cetera, et cetera. So we don't cry wolf at SEMA. There's enough actual risks you should be worrying about on a regular basis, like developer retention, like security warnings, like open source risk, IP risk, if you're in a diligence. But we, as one of my friends and mentors told me, I tell the truth because it's a lot easier to remember. We don't make up risks. When that risk comes, you'll know about it and you'll need to act on it. But please be thinking about it so you're not caught in a panic of figuring out how you're going to respond when this changes. Folks,
Yeah.
if there are anybody listening, I presented in London 3 weeks ago on potential future IP risks from coders using IP code, Gen AI tools to code. Happy to send you a copy.
Yeah, interesting. Yeah, that's a great resource. Actually, that'd be really useful. So we're talking about open source. Maybe we should go a little deeper into that, because I think that's another interesting topic when you're talking about development, and it is in some ways similar and in some ways different. Uh, and of course, we've been using open source software for a lot longer, so there are definitely more practices and a lot more of it out there, right? So, what are the risks there, and how would you suggest companies think about mitigating that risk?
Yeah. So the good news, as you said, it's been around for so much longer that folks have really had the time to prepare, to really manage open source the right way. This is
Mm,
going to be a broken record, those of you who heard and maybe are going to argue with me about the analogy, but I think we can agree on open source. It's an incredibly good idea. If your organization doesn't use open source, my goodness, there had been, or an even individual developer, a really good reason, because why would you reinvent a framework or build a new clock, right? Every kind of clock you'd ever need has already been invented, or almost every
yep.
kind. So it's a really good idea for the organizational throughput. It's also a really good idea for individual satisfaction, because you don't developer satisfaction, because you don't have to build it yourself. But it comes with a series of risks. Open source code has security risk, just like I said, all the others. The way that you solve that is have a high quality security tool for open source. Now,
Mhm.
most open source security risks are cataloged through CVEs, common vulnerability enumeration. And so you need an excellent CVE tool, and then you need to focus in particular on exploitable CVEs, meaning if your code is only in utilities and tools and behind firewalls, it's not nearly as much of a priority as internet-facing code.
Mm,
Um, that has to be in the developer workflow so that they're not surprised by it. The way that you remediate security warnings from CVEs is you keep the packages up to date, because the C for common, it's public knowledge, all of the security risks, or almost all the security risks, so they're on that list that exist in open source packages. And so the maintainers of those packages are
mm,
on notice, and of course they, almost all of them just love coding, and so they really want to make sure that it's they're staying in compliance. So making sure that you know how far behind you are in your packages, and prioritizing upgrades for security risk is a very good idea. There's also a code quality risk. Now that probably the primary form of that, well, there's two forms. There's a planning stage and there's an execution phase. The execution phase, the risk is the package you're using is out of date, or is no longer is supported. If it's out of date, but they have an updated version, then it behooves organizations to catch up. If it's no longer supported, that speaks a little bit to the planning phase. So given the benefits of using the right open source libraries and how much time savings it can be, it's worth some extra planning. There should be a committee or a team to decide which of these should we use. Are we convinced we should use open source versus building it ourselves? It's not always the answer. Of the problem we're trying to solve, which one solves it best in theory, and then which one gives us confidence
mm,
that those packages will continue to be supported? Is there a community backing them up, or is there an organization that will support the packages after end of life? Shout out to Hero Devs, one of my favorite companies, to make that easier for legacy packages. And so code quality is about picking the right ones, having a process to review, and then keeping up to date. Then there is intellectual property risk. I hope your audience is ready to dig in a little bit here. This was something I was so shocked by. Such an interesting topic if you care about IP and code. So,
right.
of course, you can go to an open source repository. GitHub, of course, is the vast majority, and use open source code by definition. There's no
Mhm.
gate of having to put in a credit card or something like that.
Right.
All code comes with a license, and that license can be permissive, you do whatever you want, to various forms of restrictive. Most companies' code comes with a commercial license. You can use it as long as you pay for it. That's
Right.
enforced by, they don't give you access to the code unless you actually pay for it. So it's enforced. What happens with open source code is each package comes with a license, but it's not self-enforcing because there's not a commercial gate.
Right.
For a permissive license, it doesn't matter. There are open source packages with a commercial license where you're supposed to be a good citizen and pay for it. Please make sure you're doing this. Do not free ride off of others. Pay to the level you can and then some as an organization, because it's the only way this community works.
Right.
But then let's keep going to more restrictive. The most restrictive form of licenses is something called copyleft. And how copyleft licenses work are that if you use open source code and you use it in certain circumstances, then you are obligated under the license of that code to give away your code for free. So if their code is free and you're using it from left to right in time series, if you're using that code in a certain way, your code is also supposed to be free. It is anti-commercial. It is pro-community in the spirit of many open source communities. They built it. They have absolutely every right to say these are the circumstances by which you're allowed to use it. This risk, this open source intellectual property risk, is absolutely mandatory to be ready for in a technical due diligence. If you're a Series A company or larger that has code that matters, whether or not you're a software company, you need it for certain kinds of insurance. You need it for certain kinds of procurement. And the more it builds up, the harder it is to fix afterwards. The solution to that is to have a software composition analysis tool, of which there are many, preferably putting them in the developer's workflow. So it's much better to do it midstream than to find it after the fact. And I'd really spend some meaningful education time with developers. I certainly didn't know this when I started this business, and it's not intuitive. Well, I can just take down this code. If they wanted me to have restrictions on it, they would have made it commercial. That's not true. I mean, it's very reasonable, but it's not true. And so really making sure your team knows about it, having as part of that steering committee to approve what packages, you should be looking at the license types. Now, remember, I said under certain circumstances that copyleft is triggered. In almost all cases, it is okay to use open source code if you're only using it internally for tools, etc. That's not legal advice. There are some, depends on the definition of internal. So definitely have a legal review if you're using GPL, and especially a GPL, which is the strictest of licenses. But back to the beginning, open source, definitely valuable, and the risks definitely real, but definitely overcomable with a thoughtful, I wouldn't call it compliance, I'd just say thoughtful management policy that includes lawyers, but really is driven by the engineers themselves.
But so I'm going to go back to something for a minute, because I was just thinking about this. I'm involved in another show, a live show, and we just did a series this summer on application modernization. And one of the topics that keeps coming up, and I guess, just my spending time in software for so many years, obviously this is something that we've talked about with companies a lot too, but technical debt is obviously something that's very difficult for companies to deal with. So I'm curious about how you can help them understand that debt and then manage it more effectively.
Sure. Completely agree with the premise. And just like all companies have security debt, all companies have various forms of tech debt. Our terminology, so the audience can follow, we think about functional requirements. What is it doing? How well is it doing that? And non-functional requirements. For non-functional requirements, we use it synonymously with code base health. And so as an inclusive term for security debt, intellectual property debt, traditional code quality debt, and so forth. And so when we say code quality debt, it is factors that either lead to slower throughput for engineers. It makes it harder for engineers to get done what they need to get done, or leads to a diminished or deprecated user experience. So we like to say it's tech debt if it creates problems for the engineers, or it creates problems for the business or for users. One of the things to do is to make sure that there are, so I guess, what do we do? So we're in our report version. Please feel free to ping us in January, and if you want to get on the beta list for the SaaS version. But the way that our report works is we run a series of tools. Of the 50 major metrics we care about, 8 of them are related to technical debt, with measures like unit test coverage and excessive complexity or duplicate code. We benchmark those to understand where they fit. This is a common theme. And then we translate it into dollars and cents, which is something I didn't, was another lesson, I think, of contextualizing it to make sense for other audiences. Yeah. For us, dollars and cents is about cost to remediate, because that's actually common across all of these different forms of code-based health. Security warnings could generate a leak, a breach, a hack, and so that economic impact, is different. But fundamentally, any of these kinds of debt still take developers time to fix. So if you can reduce technical debt to how many person hours will it take, and what is the wage rate of those developers that would be fixing that code, well, then all of a sudden you can do a financial heat map. All right, this code base, our legacy product, has $10 million of tech debt. Well, we're turning it off in 6 months, so we're just going to skip it. This legacy product we're turning off in 2 years, and it has $10 million of tech debt. 2 years is too long, but what of that $10 million is actually worth tackling? And if we invested some, what would we get from it? So the dollars and cents side, in terms of cost to remediate, really makes it easier. I know too many engineers who, and this all comes from the right place, who love code and love code quality for its own sake. That's one of the things that makes code a craft. Given the amazing advantages of being a developer, developers just have to be willing to explain why they care about the stuff that they care about in a way that that their audiences understand. And that definitely means risk to the business, benefits to the business, and cost to fix. And I understand, and I promise you'll get a lot further by saying, instead of, we need to add more unit tests because it's the right thing to do, but instead say, our unit testing is in the bottom 5% of companies of our size and stage, and I'm looking for $100K investment of developer time, because they're going to be spending 5% of their time each week working on this using Gen AI to build unit tests, which is in many cases not always a good way to add tests. So can we please make an investment in the roadmap of $100,000? That is a much more likely argument to win than saying it's the right thing to do, because whether or not that's true, that's just not the framework that the finance team, the CEO, the board of directors is operating under.
Yeah. I mean, that's I've never looked at it that way, but I think that is a really valuable way to do an assessment. It's a value assessment, right? What's the risk? What's it going to take to mitigate? How far do I need to go? And then put that all in the context of that application. What's its function? How long is it going to be around? Is it critical? That's a really good methodology and a way to think that through, I think, for companies that maybe a lot of them haven't really done when they're going through this process. It's easy to say, hey, we have all this technical debt, we have to fix it. But the truth is, do you really need to spend $10 million, or can you spend $100,000 and get to the same place, or get to a better place?
Or a good enough place.
You saved a whole bunch of money.
Exactly. And why specifically? What we always boil it down. You can't, if you work with SEMA, you can't say because it's the right thing to do.
Yep.
Whether or not that's true, where our job is to translate back to the original FlowCat SEMA to make sense to others, put it in business reasons. If we don't do this, we're going to lose customers. We're going to have churn. We're going to not be able to take on new customers. Or for the development team, If we do this, developers are going to be 5% faster, right? That unit tests pay for themselves because it leads to more throughput. But you have to explain it in terms of business outcomes, engineering outcomes, or both. Or unless you're in a really special kind of organization, you're just not going to get approved.
Yeah. Yeah, that's logical and a good framework, I think, in the way to look at it. So we're running near the end of time. Well, for the show anyway, that sounded a little ominous. And so I just wanted there's one area that we haven't really talked about much, and and I kind of wanted to get you to pull your crystal ball out for a minute and just tell us a little bit about where you see the role of AI going from a development perspective, but even more particularly from this idea of software maintenance and how AI can really play a role in that in the future. So, what do you see? Where is this going?
Yeah. Incredibly confident, but also not provocative, is it will increase the role, increasing reliance on Gen AI to help with software maintenance and software development
Mm,
will only continue to increase. This is a transformative technology, but it's also in the context of many other transformative technologies about software engineering that have been made coding the software development lifecycle more automated. If you look at how many developers worked on the Apollo 11 mission control. I'm going to get the numbers wrong, so apologies. It could be something like 1,000 developers built one mission control. And then when you look at SpaceX, they have something like 100 developers working on 10 different mission operating systems.
yeah.
And so even before Gen AI, it was an individual developer could do 1,000 times more than before. And that's open source, that's IDEs, it's version control systems, etc. And so, yes, of course, we should be intentional about this, but let's be honest, it's part of the more and more automation of the software life cycle that's happened over time. So I hope you're more excited than you're fearful. That said, there are Gen AI is going to be helping in all of these, at every stage, from product requirements to understanding code to adding tests. Self-correcting is already there in small ways, and what you can accurately and safely self-correct is only going to increase as AI gets smarter and smarter and more knowledgeable.
Yeah, makes sense. So that's all the time we have today. Really good conversation, Matt. I really enjoyed it, and I feel like there's a lot of really good info in there for the audience. Before I let you go, though, the one thing I like to get at the end of the show is a recommendation for the audience. Somebody, a thought leader, an author, somebody that you think the audience would benefit from being exposed to, either following or reading or whatever that might be.
Sure. I'm going to fight the premise and name three, because you're not going to find me. You'll see if it me out. One is Brian Kaplan of George Mason University, an incredibly thoughtful scholar on public policy and leading your best life. I cannot recommend him enough. He just wrote a benefits of more housing as an example, but he's written on so many topics and an incredible polymath.
Nice.
Second is the best author on AI and private equity and investment. And so if you're in those fields, absolutely follow him and his newsletter. It's fabulous. And then number three, overall, the best AI thinker for a broad audience is Ethan Mollick of the University. Sign up for his newsletter. He is the absolute best in capturing broad trends and also practical tips on getting the most out of AI.
Great recommendations, and we'll get all those in the show notes so that the folks can check it out. And Matt, really, again, thank you so much for joining today. Very, very informative episode. And that's the show for this week. Thank you all for joining us. Remember to like, share, and subscribe to the show. If you enjoy the show, please leave us a review to help others find us. For more research on AI and other software, check out arionresearch.com. If you're an expert in AI, generative AI, or business automation, either as a provider or an end user, email your information to disambiguation@arionresearch.com. Don't forget to join us next week. Disambiguation is an Arion Research production. I'm Michael Fauscette, and this is the Disambiguation Podcast.